Okay, so we're really going back to, yeah, yeah, I'll check the pause. So you copied this one already. How much of what you copied there was familiar? Do you kind of remember anything about the graph? Um, yeah, I mean, this is, so we have two sections here, right? One of them is talking about the standard form of a quadratic function, and then the next section is talking about the vertex form. And they both, we learned something from both forms. We know that the standard graph of a parabola, or of a quadratic function, is a parabola. And usually if you ask students to describe it, they're going to say it's like a U, okay, which is not bad. It's actually a very precise shape, right, a parabola. It's got some very special characteristics. Does anybody have a satellite dish at home used to get your television? Maybe? Nobody? I don't believe it. I mean, their shape is a parabola because of this one characteristic of a parabola, which is that if you shine parallel rays into the back of a parabola like this, right, then they all reflect to a common point, which is in the middle of it, which is called the focus. So a satellite dish is constructed like that because it's taking all the rays from the satellite in space and it's trying to concentrate it into one spot. So the satellite dish usually has got a feeder horn out there, and everything is being focused right there on that. But even your headlight on your car, the back of it is a parabola. So there's a light source at the focus in the middle of it, and it shines and it bounces off the back and out the front in parallel rays. All right, that's basically what's going on with that. Okay, this is the standard form of a parabola is ax squared plus bx plus c. The parent function is just the x squared, y equals x squared. And that is a parabola which has that point right at the origin. And that point is called the vertex. Okay. So let's see. So parabola, again, it's kind of like a U. It has the point where it makes the turn is called the vertex. If you draw a line right through the vertex, and it's going to be a vertical line in any case, then the parabola is symmetric with respect to that line. So if you did in geometry lines of symmetry, then the vertical line that goes through the vertex is a line of symmetry for the graph, which means it's exactly a mirror image on one side as the other. Symmetry, I think that covers it. Now, the characteristics of the graph, and this you did not copy. Now we're just talking about the standard form, ax squared plus bx plus c. I mean, there's two things that I recall about this that I always talk about. It's included here. One is that the A determines whether it opens up or does it open down. Okay. When the A is greater than 0, then the graph opens up. If the A is less than 0, then the graph opens down. Okay, the constant term, the plus c, that's the y-intercept. Remember, what is the y-intercept of any graph? What do we mean by y-intercept? Where it intercepts the y-axis, right? But on the y-axis, x equals 0. So if you put in 0 for here and here, then those two terms are 0, and then y equals c. That's why it's the y-intercept. That's why y equals mx plus b. The b is the y-intercept. Okay, the axis of symmetry is a vertical line that goes right through the vertex. Okay, and actually we can calculate the equation for that line by doing negative b over 2a. You know, using these coefficients, right? The same ones we used in the quadratic formula. You're going to go negative b over 2a. And then x equals that number, whatever it is, That's the equation of the vertical line that goes through the vertex. Now they have one thing in here that I wouldn't make too much of right yet, because we'll get to it when the time is right. And that is to say, if the A is bigger than 1, that means the parabola is going to go up faster, right? So it'll look skinnier, right? If the A is less than 1, it'll kind of flatten out. Okay, why is that still in there? Back and back. Okay, so now if we want to graph the parabola, I mean, the most important point to get right is the vertex, right? Because that's the thing that's telling you, just where does it make its turn. In this particular standard form equation of the function, so the two things you could tell me already, right? Does this thing open up or down? Up, because 2 is greater than 0. What is the y-intercept? 6. Okay, so we know those things already, right? Opens up, y-intercept is 6. But we need to know the vertex. So the vertex, don't do that. The vertex, like we said, you calculate the x-coordinate with negative b over 2a. Now, once we calculate that number, how do you find the y-coordinate that is associated with that? Plug it back in. I mean, whatever that number is, put it in the place of x there, and you'll have your y-coordinate. So the way we would write that is like this. We would say negative b over 2a is for the x, and f of negative b over 2a for the y. Right? So that looks like this. Okay, negative b over 2a equals negative 8 divided by 2 times 2, which is 8 over 4, which is 2. That's the x-coordinate of the vertex. Okay, now how am I going to find the y-coordinate that's paired with that x-coordinate? Plug it in for the x, right? So remember, y equals f of x equals y. They're kind of interchangeable. So I would say y equals 2 times 2 squared minus 8 times 2 plus 6, which is 2 times 4 minus 16 plus 6, which is 8 minus 10, which is negative 2. So the vertex, we just calculated, 2, negative 2. So the first step, if you have to graph, first step is you've got to calculate the vertex. Okay, so now I can plot that. 2, negative 2 would be right there. Okay, now I can draw in the axis of symmetry. Right, that's going to be a vertical line that goes right through the vertex. Now, what did we say was the y-intercept? 6, right? So let me plot that. 1, 2, 3, 4, 5, 6. And now, because of symmetry, what we know is that if this point, the y-intercept, is 2 to the left of the axis of symmetry, there must be another point which is 2 to the right. So you can plot another point. Now, with those 3 points on the graph, can you see the direction of opening? You can kind of see the shape, so sketch it in. You don't have to plot any more points than that. And I know it's not a very nice looking U, but it's the best I can do. So I'm going to do the next one. I think on the next one, I'm going to have you do one and I'll do one. Okay. I think I'm going to do the one on the right and let you do the one on the left because the one on the left is easier. But here we go. The vertex, negative b over 2a, equals negative 6 over 2 times 2, which is negative 6 over 4, which is negative 3 halves. Right? Now, y equals 2 times negative 3 halves squared plus 6 times negative 3 halves plus 3. Now, at this point, if you had to calculate this, understand that you do have a calculator in your hand, right? So don't get it wrong because of that. So this will be 2 times 9/4 minus 18 halves plus, I'm going to turn this into halves because I just see that it's coming, 6 halves. So this is, the 2 goes into 4 twice, so I've got 9 halves minus 18 halves plus 6 halves, which is what? Negative 3 halves. So my graph, if I'm at negative 3 halves, that means I want to be in the third quadrant. So negative 3 halves would be about right there. Do we agree? Negative 1.5, negative 1.5. Okay, draw the axis of symmetry. Dot, 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 dot. Okay, what is the y-intercept? 3, right? In the standard form, it's up there. So if here's the axis of symmetry, and here's the y-intercept. That's 1.5 to the right of the axis. So I should go 1.5 to the left, draw another point. Now with those 3 points, and knowing that the bottom one is the vertex, sketch in the graph. Yeah. Of negative 3 over 2? I plugged it back in. I plugged negative 3 halves in for x. There. 2 times negative 3 halves squared plus 6 times negative 3 halves. And there, with those 3 points, sketch in the graph. So here's, go ahead and try the other one. Looking at that, see if you can get the other. Okay, so the calculation of the x and y coordinates of vertex, right, should have been 1 and negative 2. And honestly, half the people going around did not have the y right. Even though you had right, it said 1 minus 2 minus 1, and you still didn't get it right. So if you got a calculator right in front of you, please get it right. Okay, so 1, negative 2. There's the axis of symmetry. What is the y-intercept? Negative 1, right? The constant term. So right there. So now how can I use symmetry to find another point on the parabola? Note this point is 1 to the left. There should be another one 1 to the right. Should be at 2, negative 1, right there. So there's, with those 3 points, you can see the U, so sketch it in. Now, what is the equation of the axis? What's that? No. They want the negative 1. I mean, you see why the vertex is here. Negative 1 is the y-intercept, right? So it's actually on the y-axis 1 below the x-axis. What is the equation of that line? Okay, remember, the equation of a vertical line is x equals a number. What number is it? 1, right? The vertex is 1, negative 2, right? That point right there is 1, negative 2. So that line is x equals 1. Now, we will in this unit, which I said has a lot of knowledge kind of stuff, some of it which is somewhat familiar, like domain and range. You've done that before, right? What did we mean when we said domain? What do you remember about domain? Okay, usually x values. Does that sound familiar? And range is the y values. Well, when you have a finite set of points, it's something to go through and pick out all the x's and pick out all the y's. Is this a finite set of points, this graph? It's an infinite set of points, right? So you're no longer going to be able to just make set brackets and write down all your values. Instead, you're going to have to say things like x is greater than this, y is less than that, right? Now, when it comes to a quadratic, the domain is all real numbers, which means you could plug anything you want in for x. There's nothing that you can do to that quadratic function that would lead to an error, you know, like a divide by 0, square root of a negative, nothing. Right? So you can plug in anything you want for x. That means domain is all real numbers. What is the range? Just looking at the graph, what are the y values that would be included? It has to be above negative 2, right? The graph doesn't go below y equals negative 2. So the range would have to be y is greater than or equal to negative 2. You would use an inequality to describe it. That's enough new concepts for that slide. So now, a parabola either opens up or it opens down. If it opens up, then the vertex is actually the minimum point on the function, right? If it opens down, it's the maximum point. So if you get a question that says, here's a quadratic function, find the minimum, find the maximum, then what are they asking you for? The vertex. And how do you calculate the vertex? Negative b over 2a, plug it in, that's it. So when you get questions like that is what they're asking you for. It's just another way to say the vertex. So tell whether this function has a minimum or a maximum. So in the end, what are they asking you for? Does it open up or does it open down? And you can tell that just by looking at it. Does that one open up or down? So if it opens up, does it have a minimum or a maximum? It has a minimum. Okay, so the first part of the question is, it has a minimum. Okay, the second part is, find the minimum. So okay, how will I find the minimum? Okay, well understand, you know, if I go back to this slide here, it says that it's the y coordinate. It's not the x value of the vertex that gives you the minimum or the maximum. It's actually the y coordinate, right? So it's two steps. First, we need to find the x coordinate so that we can plug it back in, and then the y coordinate will be our answer. So let's see, negative b over 2a equals negative 18 over 2 times 3, which is positive 18 over 6, which is 3. Okay. Now I plug that back in. Y equals 3 times 3 squared minus 18 times 3 plus 20. 3 times 9 minus 54 plus 20. 27 minus 34, negative 7. So it's at 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. There's the minimum, and it opens up. So that is the minimum. Now, if you were asked, where does the minimum occur, you would say at x equals 3. If they ask you for what is the minimum point, you would say 3, negative 7. Right? Be careful the way they ask it. A lot of times you'll have like a word problem that'll be something like profit as a function of sales, right? And it'll say, how much sales should they make in order to maximize the profit? So again, it's a quadratic function. Since it's a maximum, it must open down. You calculate the vertex. But when they say, like, what should your sales be in order to maximize profit, then you're looking for the x value, actually. They didn't actually ask you for the maximum. They just said, what would your sales have to be? So try to find the minimum of that one. What's the x coordinate? Negative 2. What's the y coordinate? Negative 13. How many say negative 13? Peter, what do you say? Did you do it? Negative 19. How many got negative 19? Me too. I want to check your math. Okay, so that the minimum value is negative 19. Okay. Now you copied this one too. The vertex form is just another way to write the equation of a quadratic function. Now, in the standard form, we had constants which were a, b, and c. Okay. Now our constants are a, h, and k. Right. But h and k are defined as the coordinates of the vertex. Right. The vertex is h, k. So when we know h now is negative b over 2a. K is f of h. They always present it in that order, where in the first section you don't use h and k, but you know all along you're doing h and k. To me, I always want to start using h and k. Now, what about the a? That's the same a as we have in the standard form, and it means exactly the same thing. It's going to tell you whether it opens up or down. If it's more than one, it'll make it go up faster. It'll be skinnier. What are the variables? In that equation up there, what are the variables? X and Y. Okay? A, H, and K are constants. We don't know what they are when we start, but they're not they're not going to vary. They have fixed values we have to find. So let's see. The characteristics now, the vertex is HK. The axis of symmetry is X equals H. It opens up if A is greater than 0, down if A is less than 0. So what can we not see directly in this that we could see when it was in standard form? The y-intercept, right? But how could you calculate the y-intercept if you've given it in vertex form? This is another one of these knowledge questions. How do you for any kind of function, exponential, logarithm, trigonometric, whatever, how do you find the y-intercept? You substitute x equals 0. On the y-axis, x equals 0. Fundamental, again, another good source of a true-false question. Taylor, pay attention? Okay. It's an example of one of those things where, we get so involved with process, but if we don't know that, then, it really shows we're too focused on process and not enough on just the knowledge. The y-intercept, substitute x equals 0. How do you find x-intercept? Substitute y equals 0. Always, right? Never changes. So graph this function. Again, I don't have to calculate the vertex, I should be able to tell the vertex just by looking at the equation. Remember that this is the vertex form of the equation. Y equals A times X minus H squared plus K. And I know that the HK is the vertex. So tell me, in this problem, what is the vertex? Say again? Y negative 2. Right. Remember when we were doing the zeros versus linear factors, right? If you had a zero that was negative, then the linear factor was plus. It's the same thing here. The minus is in the formula right there. So if it says plus 2, it must be x minus negative 2, because that's what makes it x plus 2. So it would be the x coordinate is negative 2, the y coordinate is positive 5, because that is a plus there. So negative 2 comma 5. Now, you don't have to find the y-intercept if you need another point. You could plug in any value you want. If you want to plug in, if I plot the negative 2, 5, that would be right about there. Does this one open up or down? It opens down because A is negative 1/4, less than 0. Maybe you want to plug in negative 1 because it's closer. It means the numbers will be simpler. But if you wanted to do the y-intercept, then it would be y int. We're going to go y equals negative 1/4 times 0 plus 2 squared plus 5. Y equals negative 1/4 times 4 plus 5. So negative 1 plus 5. So that gives us another point. Okay, now I still know that the axis goes right through the vertex. That's not going to mess me up. So what is another, how can I find another point on the graph? Symmetry, right? If this point is 2 to the right, then go 2 to the left. Looks like negative 4, positive 4. Okay, there's my 3 points, so I can sketch the graph. So again, I'll tell you that the domain of this function is all real numbers. For all quadratics, it's always all real numbers, because there's nothing you can plug in that's going to lead to a divide by 0 or square root of a negative. What is the range of this function? It goes up. It looks like it has a maximum point at negative 2, 5, and it goes down again. What is the range? Yeah. All reals. Y is less than or equal to 5. And you can see, remember they said that if the absolute value of A was less than 1, this thing ought to be kind of more flattened out. And you can see this one is, compared with the ones we've done before, a little more flattened out because it's 1/4. Okay, let's see. So I'm going to do the one on the left, and you could do the one on the right. So the vertex, -2, -3. I substituted x equals 0 and solved. I got y equals 1. I hope that's right. So I'm going to graph -2, -3. That would be third quadrant. -2, -3. It's going to open up. It's got a y-intercept of 1. So draw in my axis. So if this point is 2 to the right, then I'm going to go 2 to the left. Sketch in my U. What's that? I did. 2 squared is 4. 4 minus 3 is 1. You asking right here? 2 squared is 4. 4 minus 3 is 1. So try to do the one on the right. Okay, so again, from the equation, you can read the vertex, right? You no longer have to calculate the -b over 2a. If it's in vertex form, you just read it. 1, 5, done. Okay. And now, when it's around the y-axis anyways, then that's a pretty easy point to solve for. So I put in 0, -1 squared is +1, but then there was a minus in front. So -1 plus 5 is 4. So there's my axis going through the vertex. This point is 1 to the left, so I should go 1 to the right. Make a point. Oops, that's bad. Because there's in the formula, it's x minus h. The minus is part of the formula. Most of these, the directions usually do say label the vertex and the axis of symmetry. So the vertex is 1, 5. The axis of symmetry is x equals 1. And if I go back, well, you could see in the formula, if you're looking, Michelle, the formula says x minus h. So like we had in the second problem, when it said x plus 2, that meant it was -2. X minus -2 makes x plus 2. But this one, it is a minus. It is a minus, so that means the h is positive. Okay. So let's say that I have, like on the previous slide here, what if I wanted to put either one of these two into the standard form? They're in the vertex form now. What would it mean to put them in the standard form? What's that? That's linear. We're talking quadratics now. If I want this to be of the form ax squared plus bx plus c, what would I do? FOIL x plus 2 times x plus 2, and then minus 3. Right? That's if you're asked to go from a vertex form to a standard form, it just means FOIL that, combine like terms. Done. But what if you want to go the other direction? What if you got it in the standard form and you want to put it into a vertex form? That's what this one is asking about. Okay. And in fact, there is a process to do that, and we've already done it before. It's called completing the square. Right? If I need this thing to look like x minus h squared, Well, how do I make a binomial squared? I make a perfect square trinomial. And how do I make a perfect square trinomial? I pick the right constant to add to the first two terms. That's called completing the square. So this is what it would look like. Right, y equals, right, you complete the square on the first two terms. Right? So usually you would put it in parentheses like that, leave the 22 outside. And then remember, how is it that we pick the number that goes here so that we have a perfect square trinomial? What's the math? Silence. I'll just talk to myself, okay? Half the middle term squared. You were thinking of that, right? Well, if you just keep it in your head, then I have nothing to go off of, right? So negative 10 over 2 is negative 5, right? Negative 5 squared is 25. So I put in a plus 25. Now remember, when we completed the square to solve an equation, then if we added something to one side, we had to add the same thing to the other side. But we don't want to add something to the y. We need it solved for y. We don't want to add 25 to this side. So what could we do instead of adding 25 to this side? To balance out the fact that we just put a plus 25 there? We subtract it at the end. Okay, so it's almost the same process with that one little difference. Instead of adding that number that we just put to both sides, subtract it at the end. Okay, now it balances, right? We added 25, we subtracted 25, all on the same side. Now, what does this look like? X minus 5 squared minus 3. Right? X minus 5 squared, that's how that factors. And 22 minus 25, negative 3. So you know those problems at the beginning when we had to do negative b over 2a to find the x coordinate and then plug back in to find the y coordinate? Or do this, right? That's what you would have gotten if you did the negative b over 2a. That's what you would have gotten if you plugged it back in. Okay, so what is the vertex? Positive 5, negative 3. What is the axis of symmetry? The equation for the axis of symmetry. It's x equals 5, right? It's a vertical line going to the vertex. So remember, a vertical line is x equals a constant. So what constant is it? It's 5. X equals 5. Is this vertex 5, negative 3, is it a minimum or a maximum? Because? You're right. Why? Because what is positive? The A is positive, so it opens up, so the vertex is a minimum. Okay? Then what is the range? Come on now. I'll go. To negative 3, right? The lowest y coordinate is going to be that. Yeah, you did the x, but it's a range, so it's going to deal with y values, not x values. Yeah, I mean, that's not part of all this problem, but it kind of is good as place as any to, if I do 5, -3, that would be second quadrant. So let me go 5, 2, 3, 4, 5, -3. The y-intercept was 22, so it was way the heck up there. So again, you can see that the graph goes down as low as -3, and then it goes back up again. So you would say that the range is y greater than or equal to -3. Definitely greater than or equal to, right? Because it does have a value of -3. What else? What is the domain? All real numbers. All polynomials are all real numbers. All. Okay, what is the domain? All real numbers. So clear as mud. So try to do that. Put that, use complete the square to put that into vertex form, and then we'll call it a day. Okay, remember the process. Right? You're completing the square on the first two terms, right? The quadratic and linear terms. So I put those two in parentheses and leave a space because I know I'm going to add a constant, right? And I leave the plus 17 outside the parentheses. Okay. How do I calculate the number that completes the square? Half the middle term, half of the middle coefficient, -8 divided by 2 squared. Right? That's -4 squared is 16. So put a 16 there. But you can't just put a 16 there without balancing it out by doing something somewhere else. So I subtract 16 at the end. So it's x minus 4 squared plus 1, which makes the vertex +4, +1, axis of symmetry, x equals 4. If you got to say an axis of symmetry, let's say, I said, what's the axis of symmetry? And you say 4. Sorry, 4 is not a line. X equals 4 is a line. Okay, you got to have the x in there. Because you may think it's y equals 4, and now you've got a horizontal line, and that's not an axis of symmetry. So we're going to save this stuff because it's too much. And we are not doing all of that because we didn't get to everything. But we did do that stuff right there. We did above the blue line.